One of the major places that we encounter rational equations is when two people or machines or what have you are sharing a task. What do I mean by sharing a task? For example, consider this story. Suppose Janice and Ellen are stuffing envelopes for a mass mailing. Working alone, Janice could stuff all of the envelopes in 3 hours, while Ellen could stuff them all in 6 hours. When they work together, they take 2 hours to finish the job. How should we understand this? Janice could finish the whole job in 3 hours, while Ellen would take 6 hours. That means every hour, Janice finishes a third of the job, while Ellen finishes a sixth of the job. If they both work for 2 hours, well, Janice will finish 2 times 1/3 is 2/3 of the job, while Ellen will finish 2 times 1/6 is 2/6 or 1/3 of the job. That means that between them, they finish 2/3 of the job plus 1/3 of the job. That is 1. They finish the whole job. So when they were sharing the task, we figured out how much Janice did and how much Ellen did, added them together, and we hoped to get the whole job. This is how we're always going to understand these working together sorts of problems. We will always set one of these up as the amount that the first person or thing did plus the amount that the second person or thing did, giving us the whole job. And now the key thing to remember is whoever's faster does more work. They are not sharing the job evenly. They're working for the same amount of time, so the faster person does more work. It will not make sense in these situations, therefore, to, say, average out the times or anything of that kind. In fact, what do we expect to see? We expect that when working together, they'll take less time than either person working alone. After all, that's why people work together. So, in the next video, we're going to see a couple of examples where we're trying to solve problems like this with various quantities unknown. Keep this equation in mind, and also these two ideas, as they'll make this process more logical.